Okay, we're going to look at some different types of energetics calculations. The first sort of calculation we're going to have a look at is using Bond's energy data. So for this one, we're going to have a look at this reaction. So it's a reaction of ethene with fluorine to form difluoroethane. And what we'll get with these sort of questions, you'll get a little bit of data that looks like this. So this gives you the energy required to both break the bonds, so the energy you need to put in to break those bonds, and the energy that's given out when those bonds are made. And to work out the change in energy when we go from our reactants here to our products here, the way in which we do that is we calculate the total energy that we need to put in to break the bonds, and then we take away the total energy that's given out when the bonds are made. So just to simplify that statement, okay, just something that might be a bit easier to remember in an exam, we can say energy in minus energy out. So let's have a look at how we go about this. So we can split the equation in half. Okay, so on the left-hand side, we have bonds that require breaking, so energy that we need to put in. So if you don't have the displayed formula, it's quite useful to draw that displayed formula. So I recognize that C2H4 is a molecule of ethene. So we'll have this displayed formula, and that's reacting with a molecule of fluorine, F2, which will look like this. So we need to add up the energy required to break all of those bonds, so the energy we need to put in to break all those bonds. So I can see I've got one double carbon bond, so that's 1 times 614. I've got 4 CH bonds, so that'd be 4 times 413, and I've got 1 F2F bond, so that's 1 times 155, and we total those up, and that gives us a value of 2,421. We then go to the other side of the equation and work out the energy given out when all the bonds in this molecule are made. So we can draw this molecule out. And now we can have a think about the bonds that will be made. So first, recognize there's a 1 carbon to carbon bond, so 1 times 348. We've got 4 carbon to hydrogen bonds, so 4 times 413. And then finally, we've got 2 C to F bonds, so 2 times 485. So we total all those numbers up, and that gets a value of 2,970. And once we've done that, one final step, so we're going to use this equation in blue, so energy in 2421 minus energy out 2970. So our energy change is minus 549 kilojoules per mole.